Um, Thanks to all of you who decided to stay this long and join us for fun. Yes, so I know that we look really, really scary, especially me, but if you would want to just come closer and kind of, I don't know, have a chat with us, if you're interested in that, that would be really, really nice. Great, awesome. Cool. Just a quick question because I'm interested. Hands up if you're here because you're using multi-attach. Nope. There's one. Awesome. We will talk. You should come to the forum session tomorrow. All right.
We work for the same company, so.
Oh, nice. Good that you got us, people. So, so you guys who didn't raise hands, are you trying to figure out what this is? Okay. So our talk will be a little bit more about history and a little bit less about what this is, but Matt will describe what this is.
Sure.
So, volume multi-attach. It took us a couple of years. Thank you. To get there to implement this thing so you can attach a single volume to multiple Nova instances, which sounds really, really easy. I know that a couple of other systems before Cloud and before OpenStack knew how to do this, and it took us years to figure it out, but it has reasons, and this is what we will try to describe you today, and we will also let you know what the feature supports today and what we plan to implement in hopefully the near future. And
so one of the, my name's Steve Noyes, I'm from Oracle. One of the reasons that we got involved in the multi-attach effort is that Oracle has a product called the RAC database, which is the highly available, scalable database that is a shared everything cluster. And when you're in a shared everything cluster, all the nodes in the cluster, you're scaling out again, across multiple machines, need access to the same disks. So you have lots of processes on lots of different nodes all accessing the same files out there. Now when you do that, you can't do that with your normal file systems. You have to be using some form of clustering, right? So you're up a level. But you have to make sure that the underlying infrastructure that you're running on will allow you to connect safely to these disks from multiple machines. So that was really the trick here, and that was the motivation of one of our interests. So that's just a classic sort of clustering application that requires multi-attach.
So the next slide gives a brief history on the development of this feature. The Cinder team had started talking about this back in the Grizzly release, and then by Kilo, they had made the API changes in Cinder to add the multi-attach attribute to the volume resource. After Kilo, the integration of this with the compute service, Nova, had stalled out. And so by the Mitaka project team gathering, the Nova and Cinder teams were having some more serious discussions about how we sort of kickstart or get going the integration of Nova for the multi-attach feature. And the early patches to do that were basically kind of a bolt-on to the existing volume attach flows in Nova, which was kind of a problem with a lot of the Nova core team because a lot of that code had a lot of technical debt on it. So we were talking about adding more complexity to already technical debt paths in the Nova code. By the time we got to the Newton Summit, we had this session about multi-attach. We came in with this, this is sort of the design and plan that we're going to try to do for multi-attach, and we ended up leaving that session with a completely different, we need to just overhaul the API interaction between the two services. So by the Okada Summit, the Cinder team had been working on this new attachments, this volume attachments API. I was using microversions. So in Okada, Cinder released the 327 API, which is kind of what the bare minimum for any of this was going to work for Nova. By the time we got to Pike, we had the design for the Nova integration pretty much ready to go. At the PTG in Atlanta, we were just talking about upgrades, edge cases, and data migration, so we could migrate all of the old code off of this, the old way that we did attachments. And then by Queens, we delivered the integration in Nova. So as I mentioned, the stalling of the integration in Nova was because of a few things. So for anybody that doesn't know, Cinder and Nova used to be a single project. It was Nova originally, and then Nova Volume, the service, was split out to be Cinder, I think, in Essex, And because of that, you can imagine there's a lot of existing technical debt between the projects. So Nova knew the internals of how Cinder worked, and Cinder knew the internals of how Nova worked. And because of that, a lot of the APIs were just sort of, very tightly coupled. Yeah, and there were things in Nova where there was sort of the split brain checking of status on anything. So rather than Nova let Cinder be the source of truth for how volumes work, we would be like, well, they'll catch us if we're wrong, but we're still going to do some checks and stuff like that. So there's a lot of that was kind of the technical debt complexity and why we didn't want to just bolt this all onto all the existing stuff. So that was why in Okata we started investing in decoupling the APIs.
So we kind of joke about how this has taken years to get here, right? So the reality is, as Matt pointed out, there was a lot of flailing efforts and stuff like that early on, mostly because some of us, namely me, tried to do it the wrong way, right? So the reality that we kind of learned is trying to do a cross-project change of this magnitude actually takes a lot of planning and a lot of sort of program management skills and things like that. And that's kind of something that we kind of missed in the first place, right? So there was attempts that were made to do multi-attach initially early on that, hey, we'll just hack this code into Cinder and make it kind of work, which was neat and it was clever, except for when you turned it on inside of a Nova environment or a real OpenStack cloud deployment and tried to run it, everything blew up and fell apart, right? So that was bad. And then I compounded the problem by just, hey, I'll just write all new APIs inside of Cinder. And we'll just say, hey, here's new APIs and use them. Yeah, well, that's great until a customer upgrades and tries to use their OpenStack cloud and nothing works the same way as it used to, right? So Barcelona at the Okata Design Summit, that's when we kind of all got together and sort of started talking through this and working together, which is when things really came around, so.
All right, I will start. So one of the hard parts of making this happen is really to get people's attention from both affected teams. So if you ever have to land a feature in the future where you need the consensus from multiple teams, project teams, then prioritize that from like day 0 or day -1. Because otherwise your life will be really, really miserable and painful because they are just all cats. They all like to go into the direction that they prefer and then they have their own set of priorities. So when you get Cinder people to review patches and things start to merge and the priority is high up, then you walk over to Nova and then you get the look and it's like, yeah, well, we have way more important things to do. Yeah, we know that you were here a half year ago too, but oh, well, we will try our best. And then it can go on and on. So you get the consensus from the project teams, and then you also need to bug people to do those reviews, to do the code changes that they signed up for. So you need a little bit of patience to do coordination. And then once you get that, you will figure it out that the design that you agreed on a design summit or at a PTG that wasn't exactly perfect, and all the teeny tiny little features in Nova that who knows who uses, they are still breaking our brilliant plan on how to execute multi-attach, and all the design and everything gets into a big question mark state. So there are some things that are hard to solve. I don't know whether you guys feel like adding.
Yeah, one of the major things was just we try to put a big emphasis on making upgrades as easy as possible. And like John was saying, instead of just like dropping a new API and then all of the existing SDK client tooling out there just starts breaking, you have to provide basically a bridge between the way that things worked and the way that things you want them to work. And then a lot of complexity goes into both services as far as we need to straddle both of those. and providing the transition so that operators don't have to do. A big part of it for me was that you can install Cinder and Nova at separate versions. You can be running them at separate versions. And very early on in OpenStack, you basically had a monolithic install of OpenStack, and everything had to be upgraded at the same time. Otherwise, you really didn't know what was going to work. And people still, I think, have that mindset that they do that today, but you don't really have to do that. That's why we have versioned APIs and services, so that we can run them at different versions.
Yeah, to kind of add on to that, that's the thing that's been really interesting being in OpenStack for a while is, a number of years ago, we would have done kind of the approach that I started with and said, hey, here's a new API and implement it here and deprecate this one and hold on and hope it works out, right? The thing that's really cool about what we did here that I think is some of the significance might be lost a little bit, Matt and Ildiko and Steve and a number of other folks spent an awful lot of time ensuring that everything is compatible. And what I mean by that is literally, as Matt pointed out, you can take the new Cinder release or the new APIs and everything else and deploy them. You can do old Nova, old Cinder, you can do new Nova, old Cinder, so on and so forth. But you can do all these different combinations and everything else, and all of the behaviors that you're using in your production cloud today will still work exactly the same way as they always have, without breaking anything, without changing responses, anything like that, right? So everything will work as expected. And that's actually, in something as large and complex as OpenStack, it's actually kind of an amazing thing, if you ask me. So I think, the Nova folks in particular and these three deserve like huge kudos. Because I think it was like 6 months in and I gave up. So, but not really, but kind of. But anyway.
Yeah, just to add to that, and one of the challenges there, if you think about it, is live migration, right? If you're having two different systems, they could be running different versions of Nova, different versions of Cinder, and you still got to have live migration working. So that presents all kinds of challenges and testing nightmare scenarios and everything else. So the complexity was quite large on this.
In the existing attach flow and stuff was crazy to begin with, right? So the things that we did to begin with were not desirable.
Right, so we already talked about forward and backward compatibility being difficult. The way that Nova and Cinder both manage changes to the API is through microversions. So if you don't know what microversions are, it's just a version change on the API that clients opt into. So you could basically pin all of your application code to use whatever version that it understands, and then the server is not going to change the response or the way that the request is handled. And when you need something newer, you opt into that change, and it's all discoverable, and you can check to see, is Cinder new enough to provide me with this feature functionality? And in the multi-attach case, Nova is the client in all of this. Cinder is providing this capability. Nova needs to be able to tell, is Cinder new enough? And within Nova, you can do rolling upgrades, so the computes that are running all the VMs, those can be at back-level versions. So the Queens control plane can be running Queens and support multi-attach technically in the API, but if the computes are still running older code, then you can't actually do any multi-attach on that because it's just code that doesn't exist with the multi-attach feature. So we're doing all of this version checking and compatibility and stuff, and that's kind of why we said, like, you can upgrade the services at different versions, and the control plane is still going to be saying, yes, you can do this now, or no, you can't do this now. And then for everything that has been, all of your data that's already in the database before you upgrade to this point, the way that we wrote all of this and designed it was basically it's all conditional. So if the thing was attached the old way, you go down all of this old legacy code path. Once it starts getting attached the new way, then you go down the new code path. And then we do online data migrations. So when you access the old data, we basically reformat it so that it's the new flow. So eventually when we can get rid of all of this old data, we can just drop that old code, and it's not a maintenance issue anymore. We talked about non-disruptive API changes. I don't think when this started we really appreciated all of the different parts of the compute API that would be affected by this, because we just think it's just attaching and detaching a volume. Maybe boot from volume is a thing. But then you start thinking about, well, we've got all of these different types of migrations. You've got rebuild with a volume attached to it, shelve. If you retype the volume, that triggers a callback into Nova to do a swap volume operation. There's just all this stuff. So when we were designing this, the approach we took was really from the bottom up. So all of these operations that are handled in the compute service, we made them multi-attach capable, or they were able to handle the new flow. And then literally the code changes were all written in a series so that at the very end we had the API changes in the controller. And then you can test the entire stack from the top down, and nothing in the API in the compute service turns on the feature until everything below it is ready to go.
So we talked a little bit about that Cinder was initially in Nova, and then it got split out, and we got into split brain situation. So the first example to that one is check attach, because there were still some functionality staying in Nova that wasn't supposed to be there. So Nova was always checking the volume status before doing an attach, and the exact same check was performed on the Cinder side as well. So why would you do that on both sides? And then at least I thought that, okay, if we are doing this whole thing, then let's start to clean things up. And it seemed pretty easy, except there was one place where we run into problems. I think it was boot from volume.
Yeah, when you're creating a volume-backed server, the API doesn't know what host it's going to end up on, and so we would have this check in the compute service. Once you actually ended on the host, that would do these checks. So again, you sort of get into this. If you want to support rolling upgrades, the control plane needs to know: is the possibility of this ending up on old nodes, is it going to be tolerated? So you sort of have to do all of this version discovery and negotiation in the control plane.
Yeah, so we needed to add a little bit of workaround, because there were some calls like not reserving the volume in one of the boot from volume scenarios, which basically led into the fact that Cinder actually never checked the volume state. And when we wanted to remove this check attach function from Nova, then it turned out that in that particular scenario, no one checks anything. So we had to work that one out. So I think just landing the check attach removal took me like 2 months or something. I don't know. It was.
I feel like it was longer than that, but
maybe it was longer
months,
than
yeah.
that. So yeah, small things like this. Want to take the connection info?
Sure. So one of the, as Matt talked about, because of Nova splitting off from Cinder, connection info was one of the key items that was, or Cinder had a lot of information that it would stash in there, and Nova didn't want to, but it was making use of that information, and that wasn't good. In fact, I remember a couple times where I ended up, when I was coding on this, I didn't realize all this history, and I was peeking into there and looking at some of the fields in there, and I think Matt rightfully pointed out, you can't look in there.
yeah.
You have to assume that's a black box.
It's essentially, this field is essentially an unversioned JSON dictionary, and it changes per Cinder driver. So whatever your Cinder backend is using can put all sorts of random stuff in there. So it's just, and Cinder has like, what, 1,000 different vendor backends, so.
It's 1,002.
Okay, yeah, so. It's just a mess. And Nova would also use it conveniently to stash state between the different methods and stuff. So it was just a sort of a weird, like, rather than refactor a bunch of code to pass this thing that I need from A to B, I'll shove it into this thing that's already going from A to B, and that just, hope it works.
Yeah.
It was heavily abused.
Yep.
So,
Talk about that. Shared targets.
yeah. So the other thing that's kind of interesting is shared targets, and what that is in particular in iSCSI, some devices create a unique target IQN for every volume, right? But it turns out there's also a lot of devices that actually create one target and share them across every volume on that device. So big deal, right? Well, the thing is the way we did this new API for the attach, because we wanted it to be simpler, was we made we made attachments independent, unique API objects. You can create as many of them as you want, and you can delete them all the time, right? So they come and go. Great theory, great idea, and everything else, until you get into the shared targets. Because what that would mean is if you had two volumes from the same device attached to the same compute node, and you called an attachment delete on one of them, it would delete that target, because it didn't know anything about shared targets, didn't know what it was. It would delete that target, and your other volume would now be disconnected, and nobody would know about it. Right? So that was really bad. So we realized that there was this whole other design thing and architecture and stuff that we had to actually take into consideration and solve, right? And that was shared targets. So now what we do is when a device is using this model, because the other thing, we couldn't figure out all the devices that used it because we have so many device backends. It wasn't something that we actually knew was a thing. So then we had to, so now what we do is all of the devices that use this model have to report it in their capabilities. And when they do that, we then set a flag inside of the attachment object and on the volume that says this uses shared targets. So that now we know whether it's safe to remove that without checking if there's other outstanding connections or not. So.
Right. And the disconnect on the host happens on the Nova side. So Nova has to check this thing. As the client, again, this is, and it was a change in the API, so it was a new microversion. And,
yep.
And then Nova will put a lock on when it's doing this. So in case you've got concurrent threads that are disconnecting, we can check to see if this is safe or not to do it.
And when you first look at it, you're like, oh, this is easy to solve. Nova can just do X, Y, Z, right? But the first solution that we came up with then put us right back in our split brain scenario, right? Which we're trying to avoid. So we kept Cinder as the source of truth.
And by the way, other than all these problems, it was pretty simple, you know.
Yeah.
It's like whack-a-mole.
Yeah, because community is not hard, right? So when the whole thing started, when Cinder had their version of how multi-attach should be done, and then we started to, or well, a few of my colleagues started to implement the Nova side of it. It was really just a couple hundred lines of code with tests, so no biggie, you know, it's easy. And then we started to test it with LVM because that's the default driver in Cinder. Simple and easy, attach the volume to 2 instances on the same host because, yeah, we're just not bothering ourselves with multiple hosts when we start to test. And then, okay, works fine, great, perfect. And then try to detach the volumes, and then we ran into basically the scenario that John was describing with LVM on the same host. You detach the first volume, and then the initiator and the target just disappears, and then your second volume looks like it's attached, but the whole thing is just completely compromised. So we raised the issue to the Cinder team, and they were like, oh yeah, well, that will be easy to fix. And then that kind of never happened. And then I think just to realize that this is a bigger problem than just adding a counter somewhere took us like, I don't know, a year or something close. So by the time we got to Barcelona, we realized this is an issue. We realized this will not be another 10 lines of code to fix this. This whole thing. And then I think it was just before Barcelona in the Austin summit, like everyone was almost on the same page, and then John came up with a new idea. And then the whole 40 minutes was out of the window. So community is hard, like getting people really on the same page to understand the problem, to understand that the problem doesn't have a simple solution, to understand that in order to solve the problem, we all have to talk to each other, we all have to sit in the same room, we all have to accept that, okay, there's some work to be done. That's already pretty hard. And then you get on the phase when things start to roll and things start to work, and we were having weekly meetings because we couldn't really get on or stay on track in any other way, and you're having the weekly meetings and there are like questions popping up, just simple decisions, but there has to be someone who makes those decisions, because otherwise one person wants to do this and the other person wants to do that, and then we just don't agree on things because microversions are awful, and why are we doing microversions? But we have to do microversions because if we don't do microversions, then the whole API and upgrades, that will be really awful. So figuring all these things out really requires persistency, both from the person who's trying to get these things done, and both from the teams and teams involved and the contributors who are involved in this process. And you also have to accept that these things just don't happen overnight. So whenever you made a decision, that's just really like the first half step, and then the hard part just comes after that, because you get the decision, you finally write up the code, you spend hours, days, weeks. If you're me, then you spend weeks. If you're Matt, you spend like 10 minutes to make the test work. And then when you're done with that, then you bug people with getting reviews. And then when everything is done, you still have to do more testing, like upgrade testing, which really thanks, Steve, for doing that, because I don't think any of us would have done that if you don't step up. So testing, Tempest test, documentation, that all had to be done, and this is all something that we had to do as team effort, as a really big team effort.
But this, yeah, and this is sort of the beauty of the open source, community, though, right? Is because when I've worked on proprietary software at large, corporations, you're basically told from the top down, this is what we're going to do. This is when you need to have it done by. Quality be damned, really. Like once we get it to the customer, then we get the check clears, like then we'll work on QA and fixing it and everything. So yes, it's slow, but because so many people from different backgrounds are working on this, it turns out a better product.
Yeah.
And I still say that in retrospect, and given the complexity of what this ended up being and how it ended up, I don't think it was that slow. I still say it wasn't that slow. Once we all decided to do it. Yeah.
Right.
Once we were all on the same page.
Yeah.
So, and the beauty is it's solid.
Yeah, I just wanted to say that if we are also talking about the upsides of things, I think we improved a lot of things in both components. Like the new attach API, I think, is better than the old one was. We understand better that the computer is sleeping. Hopefully you're not. We understand better now how attach detach is working, because we really had to go back to the drawing table and just figure out the whole thing from ground zero, and not for multi-attach, just for attaching a single volume to a single instance. How do we do that? How do we do that better? How we do that in a way that multi-attach will be possible when we finish? And I think we cleaned up a lot of things in Nova. I'm sure that we have still a ton of things to clean up in the future, but the flow is a little bit maybe a tiny little bit easier to understand, and it's a tiny bit easier to maintain, which is even more important.
So to summarize some of the things that we learned, this is sort of a kind of a blueprint, I guess, for doing development in the OpenStack community. As Ildiko said earlier, if you're doing anything across multiple services, you really need a person driving that. I didn't want to put project manager on this slide, but this is a project management issue. This isn't novel to the multi-attach feature. This has been done with other features between different services. But we also see this being done with like the community-wide efforts that the TC does every release. And you basically need somebody driving all of those changes because it's across all of these different projects. So that's why Ildiko in this picture is herding cats, or thinking about herding cats. But it was really Ildiko that was driving a lot of this between the projects, making sure that we actually did the meetings, because if it was just left up to the developers saying, hey, it's meeting time, like, do you guys want to have a meeting? We would say like, no, I'm busy, I don't want to do any of this. So big efforts need a champion. The other thing is integration testing. QA is definitely key, and doing it as early as possible is key. The shared targets thing that they were talking about earlier came up simply because we wrote a Tempest test to just try this multi-attach thing, which the default testing upstream is just on a single host. So we would attach the thing twice, detach one, detach the other, and it would explode. And that was this shared targets issue. So writing a simple test just for how the API works, writing it early enough, we find out, oh, we've got this major issue that we have to solve. And then actually having the regular interlocks, like Ildiko said, we had meetings every week for, I think, the better part of almost 2 years. So, and it's not just...
It felt like 5.
Right, the people on the stages aren't, this wasn't just us. This was lots of different people from both different projects.
So where did we end up? So the requirements to actually run this, there's a few things. So you need libvirt greater than 3.10, greater than or equal to 3.10. The drivers that it's currently supported on are the reference implementation LVM, the solid fire backend driver, and the Oracle ZFS driver. Since the Okata Pike release, Queen's release, since the last release, there have been a few other drivers added as well. I think I saw one of the Dell drivers merged. I think
EMC had one.
EMC had one. I think Ceph is working
Extreme
on
IO. There was a few, yeah.
Yeah, so there's a number. So they're getting there. We have all new Cinder volume attachment APIs, which is really cool. There's still some things going on underneath that can be cleaned up and ripped out. But in terms of from a user perspective, use the new APIs if you can, because they're awesome. We don't allow retyping a multi-attached volume while it's in use, because that can be very bad. Because retype does funny things depending on how you call it or what retype you're trying to do. One of the ways that retype works is sometimes it's actually migrating a volume to another backend. And it turns out trying to do that in a multi-attached scenario is no bueno. So you don't want to do that. We don't do multi-attach to a shelved or offloaded server. So if you're familiar with that call, good for you.
Because we don't know if anybody actually uses it.
Yeah, so hopefully you're not using it. I'm not going to go into detail about it because you might get ideas and think it's cool. It's not. So just move on. And then, of course, we use the standard, RBAC policy rules, so you can set up permissions for different roles to allow this or disallow it, turn it on, turn it off, so on and so forth. Currently, we're only doing read-write for the multi-attach. So when you do a multi-attach, it's always assumed that it's going to be read-write. So be warned, if you're just using ext4 as your file system, and you do this, and you try and write simultaneously from two machines, you're not going to be very happy. There is a patch that was in progress that needs to be redone and started over that will allow specifying a different mode. So we'll get that up here pretty soon.
Yeah, so on the compute side, there are basically two main API changes that will actually be getting discussed probably tomorrow. There's a forum session here at the bottom. So for more information on the actual design and what we're going to be talking about in the Rocky release, the two big things are in Nova you can create multiple servers in a single request, and you can create volume-backed servers, but you can't do those things at the same time. So with multi-attached volumes, we should be able to say, give me 10 servers, and I want them all backed by the same volume. The API just has a check in there forever that's just said, you can't do this because it's never been supported before multi-attach. So we've got a design spec up to how can we resolve this in the API. And then the other thing was the read-only mode. So this is very basic, just simple plumbing, so that when the user attaches the volume, they can say, I want it in read-write or read-only. So you could have the volume attached to 3 different instances. One of them is write, and the other 2 are just read for backup. And then we've also got patches up in Nova for migrating all the old data, like I talked about earlier, so that we can eventually drop all this code. If you want to see a demo of how this works, there is a demo on YouTube. It goes at very high level, just like it was written right after the Queen's release. But the demo does go through command line using OpenStack client to show you how to do this stuff, wire it up, goes into the guest, like SSH into the guest to show you, it's actually connecting to this volume and writing to it, swapping back and forth. It's pretty simple. It doesn't use a clustered file system or anything, but it gives you the idea just from the command line how you can do this. And then there's documentation in both Nova and Cinder on how you configure this from a deployment perspective. And then the RBAC rules that John was talking about, if you're using Cinder drivers or you're using a Nova driver that doesn't support multi-attach yet, you can disable all of this so your users just can't try to shoot themselves in the foot in the API.
I think we are kind of done. And just one thing to add, or maybe two. First of all, thank you all, and Gibby in the audience, and the contributors who are not in this room today, but worked a lot to make this happen. It was really a gigantic group effort. And in connection to this, I would like to highlight that Steve here is working for a company who are more on the user side as opposed to on the developer side. And he is also working on upstream in really just part-time. So if you think that, oh, I'm just a user, I can't or don't want to get involved in any development activity that, by the way, we would like to use and depend on, that's not true. Please come get involved, even if it's just like, I don't know, 2 hours per day, every second week. You can get a lot of things done. Like I think we would still be working on all the tests and upgrade testing and everything if Steve doesn't show up and doesn't do a lot of work for us in really very limited amount of time. So we really are looking for, both for this feature and in the whole community, involvement from users as well. So if you find something, even if the things that we said that are missing here and that you would like to have, come show up on either of the Cinder or the Nova channel. Just ask how you can help out, because tiny little things matter a lot. And any questions?
Any answers?
You have a nice team there, so what will be the next cross-project feature you will do?
I heard there was this guy that was working on bandwidth-aware scheduling for networking, and between Nova and Neutron, it was going to be very complicated. So not this team, but that unfortunate person.
I think actually you should recruit these three.
I have to review some of this code coming up, but
I'm just a cat lady around.
yeah.
Everyone else understands what multi-attach does. Is anyone convinced here that you want to use it? Maybe?
I'm curious, and maybe it's kind of a bit out of context from all the work you did in actually making it work, but from more of a user perspective, like you alluded to the dangers of having multiple instances mount a ext4 volume and write to it, but wouldn't even, like if one instance wrote to it, another's read-only, that would probably also be inconsistent, right?
It may be inconsistent, but it won't corrupt your data.
Corrupt data.
Right.
So maybe from that, are there any cluster-aware file systems out there? I mean, I know that's a really uncommon thing.
There are actually there are a number. Yeah, there are a number of things. There are things. The rack stuff, as Steve pointed out, is the biggest thing that shows up in terms of an open source free. If there were, we would have a demo and tell you how to use it and everything else. But there's not. That being said, I have quite a few customers over the years that have been asking for this feature for a really long time, and they all are rack customers, almost every one of them.
And with rack, you don't need to understand the file system. The app just handles it for you.
There is a clustered LVM, or a clustered, now I can't think of it. There is a Linux clustered file system product that you can get, but unfortunately, again, it's not free.
I think I remember in Austin, the other one use case I remember was Trove, the database service. So if you had if you had an instance that was attached that was the read data or the write database, then you could have slave database instances to the same database cluster that were reading. So as long as you don't need the very latest, it's just it's a read slave database. But you could do this with Trove.
Yeah, and the other thing is there's under the covers things that take place in OpenStack a lot. That is where this is actually really important. So things like doing backups, things like if you want to do something really cool and smart and clever, like use a Cinder volume as glance images. There's all kinds of interesting tricks you can start playing when you go down that path and you do that. So that's where a lot of this stuff comes in, and you don't have to worry about the clusterware file system anymore, because what you're using is almost like a standby hot, thing. To be fair, doing the attachment isn't that much work, but by having it already there standing by, it does save you some things and give you some flexibility.
I think they want us out of here. I think they want us out. So thanks.
Thank you.
Thank you.